introduction to ECMAScript. In this video, we're going to be discussing what ECMAScript is. So ECMAScript is actually a standard that comes from a standards organization called ECMA International. And ECMA International is an international standards organization that is responsible not only for the JavaScript standard, but it's also responsible for other programming languages such as Dart, C++, C#, and they're also responsible for the JSON standard. Now, the ECMA International Organization has a technical committee that is the 39th Technical Committee, often abbreviated to TC39, and that is the technical committee that is responsible for the JavaScript standard. So those are the people who define the future of JavaScript. And the latest version of JavaScript is ECMAScript 2015, also known as ES6 or ES 2015. And this basically the latest features of JavaScript, and throughout the course we are using these latest features. Now, if you're curious what these features are and what future features JavaScript may receive, you can track the proposals on GitHub. So if you go to github.com/tc39/proposals, you will see a list of active proposals that may or may not make their ways to the JavaScript language. So as part of the few upcoming videos, I've selected some of the most used features of ES 2015, and these are the features that we will also be using throughout the course. So we're going to take a look at new ways of declaring variables. We'll take a look at object destructuring and object literals, take a look at arrow functions, rest and spread operators, template literals, promises, and classes as well. Now, even though ECMAScript is all about the JavaScript standards, since TypeScript is a superset of JavaScript, we're now going to take a look at these ECMAScript features so that we learn more about TypeScript as well. Hello and welcome to the next video in this section. In this video, we're going to discuss the two new ways that we can use to create variables by using the const and let keywords in ES 2015. So both const and let allows us to declare variables, and there's a slight difference between these two keywords. The most important thing is that we need to forget the existence of the var keyword. So please do not use the var keyword to declare variables. There are multiple reasons for this, and it's just good practice to stick to either const or to let. Now, both const and let are blocked scope, which means that the variables declared inside a scope, which could be an if statement or a function, are not going to be accessible outside the scope of those functions or if statements. Const variables cannot be redeclared, whereas let variables can be redeclared, but please remember that when you create an object using the const keyword, it doesn't actually make the object immutable. If you want to make an object immutable, you need to use object.freeze, or you need to use immutable.js, which is another library. So let's go through a few examples now. So here's the most simple variable declaration that you can do in ES 2015. We use the let keyword followed by the identifier, and then we assign a value to that. And later on, we can always assign another value variable, and we can actually log the variable value out and see this in action. Now I can run my code using Node because I'm using the latest version of Node, which is Node version 9, and that by default understands ES 2015 code. Now if I would do the same using the const keyword, remember what I said, const variables cannot be redefined, so we are going to present an error. So assignment to a constant variable is not possible. So when we try to reassign a value to that, we are getting an error. And I also mentioned that if we create an object using const, we can still add entries to the object. So let's recreate this code. So we have a very simple object that has an array, and even though we've defined this as a constant, we could still call push and add another entry to that. So if we look person, notice that we get that newly added item in the array as well. And let's check how these variables are block scoped. So let's create a very simple if statement, and inside here I'm going to create a variable, and if I try to access that variable outside the scope, so outside this if block, we're going to be presented with an error, and the error is going to be a reference error stating that name is not defined. Now when writing Node.js code, my preference is to always use const keyword for things that do not change. So for example, when we require libraries or npm modules in Node.js, I tend to use const. So just to sum this up for you, if you have variables that you do not plan on reassigning, so variable values that do not change, use const, otherwise use the let keyword. Hello and welcome to the next video in this appendix. In this video we're going to discuss how objects and arrays can be manipulated using ES 2015. So ES 2015 introduces a new concept called object destructuring, where we can access parts of an object or an array in a much easier fashion. So before we used to use dot walking, and now there's an easier construct to get values out of objects and arrays. Let's take a look at a few examples. So here we have a typical object, and in order to extract the name, normally we would create a variable to store the value, and we would utilize dot walking. So we would take the name of the object, dot, and then the property that we want to extract. So therefore, if we log this value out, we will see the value Steve returned for us. Now in ES 2015 there is a much easier way to do this. So instead of storing the variable and utilizing dot walking, we can use curly braces and specify the name of the property that we want to exist and make this equal to the object that we want to work with. And if we save this, the result is going to be exactly the same. And we can access not one but multiple properties as well. So for example, if you want to get the name and the age, we can access those, and then just to show you, we can print those values out as well. Now what if you want to extract the name property but you want to call it something else, like first name? In that case, you can put an alias to the property name by using the colon character and then give it a value, and now we can access that variable using that alias. And we can also utilize the structuring assignment for arrays. So we could create a simple array, and we can take one value out of our numbers array, for example, and if we log this value, we would get the first element returned to us from the array. Most of the time we would be working with objects that look like this. So this could be a response coming back from an API where we have a count property, then we have a data property that contains an array of objects. So we can very easily get all the data out from this response as well by specifying that we want to get the count, for example, and then out of the data we want to get the name and the films returned to us. So we assign this to be equal to response, and now we can log any of these details out. So what if we want to get the films, and we can just print that out and we get the film information. What if we want to get the name, then we get the name as well. So as you can see, this is really easy to do because it's not that difficult to get information out of objects or array of objects. Now I hear you ask, what happens when you have multiple elements inside this array? So you have an array of objects, so let's say like this, so you have multiple name and film properties. Well, in that case we need to utilize some sort of a loop. So for example, we can take response.data and let's call for each on it, and we can then create a variable name for each response that we have and just log the name out, and in this case we will get both of the names from the data structure that we have specified. Next modification is the property value shorthand. So the property value shorthand allows us to specify the property for a given object in a way so that if the property has a value that we have assigned to it via a variable, and as long as the property name and the variable name are the same, we don't need to specify both of those. So let's take a look at an example of this as well. So let's assume that we have these two variables and we want to create an object. So we want this object to have a name property where we assign the name variable, and then age property where we assign the age variable as well. So this would be a code that you could write today. With the property value shorthand, you can drop the duplicates, and this code is in fact exactly the same as what you saw previously. Okay, so as long as the property key is the same as the variable, you can use the property value shorthand syntax. Not least, you can also use computed property keys in ES 2015, which means that you can pass in properties as variables, so you can dynamically read out these values from objects. So for example, let's consider that we have a name_me function that takes a name, and whatever that name is, we want that name to become a property in our object as well. So what we do, we wrap that in square brackets, and then we specify the actual value for our object. And in order to call this, I'm going to wrap this in a console log statement. So I'm going to call name_me. I'm going to call that with a value, and then notice that when we run this example, the property name is computed, so we take the property name of the argument, so those are going to be the same. Now of course there's nothing stopping me from calling to lowercase on this, since this is a variable now, so I can make my property key lowercase even though it is passed in dynamically. Hello and welcome to the next video in this section. In this video we're going to discuss arrow functions and how to use them in ES 2015. So arrow functions allow us to define functions in a different way, and they are also referred to as fat arrow in some literature, and the syntax to that is the equation sign and the greater than sign together. And there are a few facts around arrow functions, and we're going to take a look at an example of each of these. So first of all, when using the this keyword, in this case the this keyword is lexically bound to the execution context. So as long as you use arrow functions, this is lexically bound. And the syntax rules around the arrow functions are listed on the slide as well. So if you specify a function where the function has one argument, there's no need to use parentheses for specifying the arguments. For multiple arguments, you need to use parentheses. Now, for the return part of the function, you do not need to specify curly braces if you have a single line of code and if you want the return statement to be implicit. Otherwise, if you want to use multiple lines of code, you need curly braces and you need to specify the return keyword as well. And finally, returning an object requires you to use parentheses around the return statement. So let's take a look at a few examples now. So here we see a classic example of using a function as a callback in JavaScript. So we have numbers.map, where we pass in a function and then we return the number from the numbers array. So if you run this example, you will see that we get a list of numbers 0, 1, and 2. So we can rewrite this particular example to use arrow functions. So remember what I said about the syntax rules. If there's one argument to the function, we do not need to specify parentheses, and we need to use the fat arrow syntax. Now, since we have one line of code with a return statement, we can make this return statement implicit by removing the curly braces as well. And voila, we have simplified our code that now uses the arrow syntax, and the result is going to be exactly the same. So let's now take a look at another example and see what we can do with regards to the lexical this. So here I have a quotient object that has some numbers, has a results array, and it has a divide function where we have a divisor, and then we iterate through the numbers array that's part of the same object, and we want to basically make sure that a number is dividable by a number that we specify for this function. So let's use our quotient and use our divide function with 3. So we want to find all the numbers that can be divided by 3. And theoretically, if we do console.log and we call quotient.results, we should see our results, because this function, this divide function, adds the values into the results array that's part of quotient as well. So let's go ahead and save this and run this example now. Okay, so we are faced with an error that says cannot read property push of undefined. It says actually this dot results is undefined, and that is because this does not refer to results inside this return statement for the function, because it only references this function. So it doesn't see the results array that we want it to. And there are multiple ways that you can solve this problem, and probably you've seen these before. If you work with JavaScript, you could create a variable called that, assign this to that, so the outside scope of this, and then instead of calling this.results, you need to say that.results. And if you run this example, now it works. Or another way to solve this, if you don't want to create another variable and you still want to use this, is to go ahead and bind this to the divide function, and in this case you get exactly the same result. Now the good news is that when you use the arrow functions, you do not need to do any of these tricks, because this is going to be bound lexically to the calling function. So that means that instead of having this function here with the dividends, we can transform this to an arrow function, and that is the only change that we need to do. And if we execute our code now, we get exactly the same results than the previous two scenarios. Okay, so let's also take a look at an example where we pass in 2 arguments to our function. So let's write a function called greet, and as I said, if you have more than one argument, then you need to specify parentheses for the arguments. And what if we want to return an object? As I said, if you want to return an object, we need to use parentheses and curly brackets to return an object. I'm using the object property shorthand syntax here. So let's see this particular example in action. So let's greet a person with an age. And if we run this example, now we get an object back. If we wouldn't have the parentheses in here, it would think that we want to return name and age, and it's just going to throw us some syntax errors. Hello and welcome to the next video in this section. In this video, we're going to take a look at the REST and spread operators, as well as the default parameters for functions in ES 2015. So in ES 2015, we can use REST parameters, which essentially allows us to pass in any number of arguments to a function and then work with those arguments. And we can access the arguments by using the 3-dot syntax. Let's take a look at an example of this now. In code written earlier than ES 2015, you may have run into situations where you had to pass in an unknown number of arguments to a function. For example, add can accept any number of values, and all we want to do is make sure that we add the values passed into the function together. Now the problem was that we could access arguments, but arguments was not an actual array, it was only an array-like object. So therefore we had to add some trick statements in order to make JavaScript think that argument is an array, so that we can actually call reduce on it and then do the actual operation. So using ES 2015, we can pass in, using the 3 dots, a variable. So let's call this numbers. And in this case, numbers is going to be an actual array, which we can access and call all the array methods on it, like reduce. And then based on something else that we've learned, we can also apply the arrow functions on this code so that we can even make our code simpler. And let's go ahead and run this example, and we get the appropriate number. If we just work with 2 arguments, then of course we get the result of that operation. Now the 3-dot syntax can also be used in another place in ES 2015. It's the spread operator, and it's especially useful when we want to combine arrays together, and that uses the 3-dot syntax as well. Look at an example. So let's assume that we have 2 arrays. We have a fruit array, and then we have more fruit as an array containing a single element. And let's assume that we want to combine these arrays together. So we could use the concat method, or even easier, we could use the spread operator to specify fruit and specify more fruit. And if we log our new variable containing all the fruits to the console, you see that we get a concatenated array. And last but not least, let's take a look at default parameters. So we can define default parameter values for functions as of ES 2015. So that means that when you specify an argument to a function, you can specify a default value to it at the argument level. For ES 2015, you may have seen code like this. So if number is not equal to undefined, then we use number, otherwise we use 0. If multiplier is not undefined, then we use multiplier, otherwise we use 1, and then we do some calculation. And then we can use the function without a parameter, with 1 parameter, or with 2 parameters. So as opposed to having this relatively complex logic inside the function body, as of ES 2015, we can move this logic and we can specify default parameters at the argument level. So in this case, if we do not specify any arguments, then 0 and 1 are going to be assumed. If we specify 1 parameter, such as 5, then number is going to be 5, multiplier is going to be 1. If we specify 5 and 2, then number is going to be equal to 5 and multiplier is going to be equal to 2. Therefore, if we run this function, we get the results of 0, 5, and 10. Hello and welcome to the next video in this section. In this video, we'll discuss ES 2015 template literals. So we can use template literals in order to evaluate expressions within strings, and the template literals uses the backticks for its syntax. If we want to evaluate an expression within the backticks, so inside the template literals, we need to use the dollar and curly brace syntax, and we need to wrap the expression in that syntax. So let's take a look at a few examples of this now. Console log statement where I'm going to add backticks, and we're just going to type in hello world, and if we run this example we'll see that there's nothing special that happens. Now you may recall that if you had to implement line breaks, you had to use the \n syntax in all the versions of JavaScript. Now you can just hit enter as many times as you want, and then notice how we get that picked up automatically because we are using template literals. And the same is true for tabs. So I'm hitting tab twice, and that is also going to be picked up in our result. Now furthermore, I mentioned that we can have expressions inside backticks as well. So let's create a variable, assign that a value, and in here we can specify that expression by using the dollar and curly brace syntax. And this is now going to, of course, yield the response hello Steve. So this particular syntax is very useful when we want to construct HTTP requests. So I'm not going to give you a full example, but just a conceptual implementation of that. So let's say we have an API key, and then we want to make an HTTP request, and then we construct the actual endpoint, and then in that endpoint we want to specify an API. So we can do that by applying the template literal syntax. So there's no need to use string concatenation and other methods that we used in all the versions of JavaScript. Hi, and welcome to the next video in this section. In this video, we'll discuss classes in ES 2015. So classes is one of the biggest additions, in my opinion, to ES 2015 and to the JavaScript language. But you need to remember that having the class keyword does not change how JavaScript functions under the hood. In fact, JavaScript is still a prototypal language, and the class keyword really just adds syntactic sugar on the JavaScript prototypes. And in light of that, there are these three keywords that we're going to be discussing. So class allows us to create a class, extends allows us to extend our class and create subclasses, and then super allows us to access the parent class methods. Of course, these concepts are best explained by an example, so let's change to our editor now. So here we have a sample class. You specify classes by using the class keyword followed by the name of the class. A class can also take a constructor. In this case, the constructor takes a make, a color, and a speed, and we assign these values to our class. That means that when we instantiate our class, we need to specify these three variables. So make, color, and speed. And we also specify a method called getMaxSpeed, so get the maximum speed, and then we're going to take the speed that got passed in by the constructor and just return this statement using the template literal syntax. So in order to instantiate our class, we need to use the new keyword. I'm going to create a variable called a new keyword, so it's a new car, and then notice that we need to specify the make, the color, and the speed. So let's make a black BMW, and 250 is going to be the speed. And then we can now call the getMaximumSpeed method, so we can call car.getMaxSpeed, and if we run this example, we now get maximum speed is 250 kilometers per hour. So we get our message returned. Okay, so far so good. So let's go ahead and extend our class. So let's create a subclass or a child class of the car class. So we can specify another class that extends the parent class, that is car, and we can actually overwrite methods. So we can specify a getMaximumSpeed method here, and we can specify that this is now a truck speed, and we're going to call this speed again, and we can add methods, additional methods to this class that are only specific to the truck class. For example, get the make of that. So we can create another variable, and we can call the subclass via the new keyword again, and let's give it some values. And we can now call, instead of car, we could call truck.get maximum speed, and it is now going to return the maximum speed of the truck. And we could also call the get make method that is going to return the make of the truck itself. Now, there may be scenarios where instead of overloading, so instead of recreating the get maximum speed method, we want to call a method from the parent class. And we can do this by using the super keyword. So we're going to get maximum speed, and instead of having to specify a return statement in here, we're just going to call super.get maximum speed. Okay, so we're calling the actual function from the parent class. The super references, as you can see, class car, so we're calling this particular method. And if we run our example with get maximum speed, we get undefined. Now the reason why we get undefined is because we need to return super get max speed. So let's go ahead and run this example, and now we get the example that we wanted to. Now the other example for using the super keyword could be used when we want to actually append the properties of the child class. So let's go ahead and take a look at another example where we're going to create a person class. So we have a constructor where we assign the name, and then we have an introduction function, and then let's extend this person class and create a superhero class. And notice that inside the constructor we take the name and the power, and instead of assigning the name for our superhero class, we take the name that will go passed in to the person class. So that means that we can go ahead and now create a new superhero. And we could now call the introduce function. And the introduce function uses the introduce method from the parent class, and the constructor takes the name of the parent class as well. So if we log this out, you will see that we get the message, hello Spider-Man, your superpower is webbing. So using the super keyword, we can access the properties as well as the methods of the parent class in the child class that we have extended. When it comes to working with TypeScript code and with TypeScript applications, oftentimes we have to write modularized code. So modular or modularized code means that parts of your application are separated in different files. And this makes sense because creating modules and creating these separate individual files helps us to maintain the code in a much better, in a much easier way. So think about a scenario where you have a small application that uses some mathematical operations. Then it would make sense to store those mathematical operations in a separate file. So I have app.ts here, and we have utils.ts in here as well. So in utils.ts, I'm going to be using one of the keywords that enables us to write modules, and that keyword is going to be export. So we can export any variable or any function or any object or anything from one TypeScript file to another. So I can, for example, export a constant called pi with a value of 3.14. And I can go ahead and save this utils.ts file, and then in my app.ts file I can import utils, and I can import it in a few ways. I can say something like import everything as math from, and then the location of the import, so that's utils without the actual ts extension. And in this case I'm importing everything from this utils.ts file, and I give it an alias called math. So I can go ahead and access math.py, which is going to return 3.14 for us, because that is the value that we have specified in utils.ts. Now, of course, this star or this asterisk character means that we are importing everything from this module, but here we are only exporting one thing, but there's nothing stopping us to export multiple things. So we could export a number, and now in our main application we could say math dot and then n to access that variable that we have exported. But we can be more selective, and we can say, as opposed to saying import star, we could say import and then specify the bits and pieces that we want to import. So we could say import curly braces and then import pi from utils. In that case we can access pi, and the value of pi is going to be, of course, 3.14. You can give this an alias by specifying the as statement inside the curly bracket. So you can say import pi as, and then give it another name, for example math, and then in this case we can access that math variable, which is going to return us 3.14. Now in our utils file, as I said, we can export not only variables but additional things as well. So let's take a look at an example where we're going to export an entire class called math module. So in that class we are going to add the method called calculate, which accepts two variables and it returns the sum of these two variables. And now, because we are exporting a class, we can try to see what happens when we are importing this module in our application. So let's go ahead and import math module from utils, and notice that we immediately get an error that is stating that module has no default export. So this means that when we have exported the class math module, we haven't specified the export default keyword. So we can go back here and fix this by saying export default class math module, and in that case we can import our math module, and we can then create a new variable and instantiate that class, and we can then call the methods on that particular class. So calculate is the class method that we have specified on math module. Now what if you don't want to use the default keyword? Well, you can still export a class, but then you have to put the math module in curly brackets. So you need to specify explicitly the module that you are bringing in from utils. And of course you can give this an alias as well. So you can give this a name, and then that is the name that you need to use throughout the application itself. Hi, and welcome to the Introduction to TypeScript course. In this video, we're going to take a look at how to set up your environment so that you are going to be ready to work with TypeScript. The first thing that I recommend you to do is to get an appropriate IDE. Now you could use the IDE of your choice, you could use any code editor that you want, but throughout the course I'm going to be using Visual Studio Code. If you want to download this code editor, you can go to code.visualstudio.com and then you will see a download button here. So because I'm on a Mac, it automatically gives me the download for Mac button, but if you are on a different environment, you can of course install it for Windows and for Linux systems as well. So please download this editor if you do not have it already and install it on your system. Once you have installed it, you can open Visual Studio Code, and this is how it looks like. And there are quite a few things that I like about this editor, and this is why I like to use it, and this is why I recommend that you use it as well. So first of all, it does have an integrated terminal which you can access by clicking on View and then selecting the option that says Integrated Terminal, and that allows us to access the terminal from within the IDE itself, which means that if we want to execute some commands, we do not need to go out to another application and open a terminal. So what it allows you to do is of course create new files or open even folders, search in them. It also has integrated support with Git, so if a particular project is under source control, it would show you the differences here. You can also do debugging within the IDE itself, and it also has an interesting feature called a marketplace or extensions, where you can install useful extensions for your Visual Studio Code editor. Now, one thing that we need to do is of course install Typescript. Now, Typescript can be installed globally on your system, and that is exactly what I'm going to do. So if you haven't opened the terminal, please go ahead and do that and type in npm-i, which is short for install -g and then Typescript. -g is an option for npm that will make a package available globally. So I want to install Typescript globally on my system so that I can access it no matter where I am or what project I am working on. Now, once you have executed this command, you can type in tsc in the command prompt and space -v. This is returning version 2.7.2, which means that you have Typescript 2.7.2 installed. Now, tsc is the Typescript compiler. The Typescript compiler allows us to compile Typescript code to JavaScript code. With these two steps, you have actually completed the setup of your environment. Later on, we're going to be installing additional things, but for the time being, you are done. So you have an editor that allows you to write some code, and you have the Typescript compiler as well installed that allows you to compile Typescript code to JavaScript. In the last video, we set up everything that we needed in order to be able to write Typescript. So we have our editor, and we have also installed Typescript globally so that we have access to the tsc command. So let's actually create a very simple Typescript code now. So in the Visual Studio Code editor, I'm going to click on this icon that's a new file, and I'm just going to call this first.ts. So Typescript files normally have a .ts extension. In some cases, you may also see a tsx extension. So what we're going to do is write a very simple console log statement here, and that is going to just say hello from Typescript. Let's go ahead and save this file, and let's now use tsc, the Typescript compiler, to create a JavaScript file from this Typescript file. Now, before we do that, let's think about this. Why would we want to create a JavaScript file? Well, you can create an entire application using Typescript code, but of course you cannot use the Typescript files in your browser, for example. So you would need to generate JavaScript files from your Typescript files, and tsc allows you to do that. So if I type in tsc followed by a space and then first.ts and hit enter, that is going to generate a JavaScript file in the same folder with the same name. So first.js is the file that got generated, and as you can see, its content is exactly the same. So don't forget, TypeScript is a superset of JavaScript, console log statements are exactly the same, so the content of these two files, if I put them next to each other, are going to be exactly the same. So let's actually go ahead and update this console log statement and write some more sophisticated TypeScript code in here. And I'm going to create an actual array of numbers. And I'm going to use map to iterate through these numbers. And then I'm going to use filter to collect only the elements from that array that are greater than 2. And I'm going to output the result in the console. So let's go ahead and run TSC again. And notice that first.js got updated so that we get a variable instead of the constant keyword. Instead of the arrow function, we get the anonymous function callback here with the number. We get the return statement, and then we get the console log statement. So as you can see, TSC has generated some very old JavaScript code for us. In fact, if you do not specify any options for TSC, it is going to generate JavaScript ES3 version of your TypeScript code. But there are of course options to override this. And we can pass in command line options for TSC. So we can go ahead and type in TSC -- target, and we can specify a JavaScript target such as ES6 for example, and then let's go first.ts, and as you will see on the right hand side, now I got ES6 specific code, or ECMAScript 2015 compliant code, so I still use the constants and I still have access to the arrow function in here. Now of course there are additional options that you can pass in for the TypeScript compiler, and under normal circumstances you wouldn't be specifying these options in the command line interface. TSC actually allows us to create a configuration file called tsconfig. So let's go ahead and create that file. And tsconfig is a JSON configuration file, so it has a .json extension. And in here, we can specify a property called compiler options. And for the compiler options, we can specify things like the target. And for the target, we can specify ES6, for example. Now that we have the tsconfig.json file in place, all we need to do is type in tsc in the command prompt. We don't need to specify first.ts nor the target. If I hit enter, and providing the fact that the tsconfig.json file is in the same place where we executed tsc from, it is going to take the settings specified in this option file and produce first.js for us, and as you can see, it is in fact using the target of ES6. Now there are additional options that you can specify for tsconfig.json, and not only the compiler options, but you can also specify things like files in here, which is an array of files that the compiler should take a look at when compiling JavaScript. You could also have include, and you could have something like star.ts in here, so that you want to include all TypeScript files in the compilation. You can also have exclude as a property, where you can specify, for example, the node module folder and in this case TypeScript files that have a .ts extension that are in the node modules folder will be excluded from the compilation process. So as you can see, there are a number of things that you can set up, and you can actually check the TypeScript documentation where you will find a list of compiler options that you can use. And we're going to be using a few of these throughout the course. For now, we have only used the target option, and if we scroll down towards the bottom here on this site, then you will see that the target option allows you to specify multiple targets for the compilation process. In the previous videos, we saw how to compile TypeScript code to JavaScript, and we mentioned that we need to do that in order to create this JavaScript file that we can then put into the browser and execute it in there, since the browser is not capable of understanding TypeScript. So in light of that, there are two ways that we are going to be using to execute TypeScript code. The first one is really going to be obvious. So we can take first.js, we could take this content and copy paste it into Google Chrome Developer Tools, or add it to a website as a JavaScript file and then execute it and see the result. Another very obvious thing would be just to run this JavaScript code against Node. So I could type in node first.js, and this is going to be executed against Node.js, and we do get the correct result of number 3 based on the code that we have created here. Another example would be to execute TypeScript code directly against Node.js. Now, in order to do that, you need to install a package globally, and that package is called ts-node. So in order to install that, we need to type in the npm install command. So npm -g ts-node is going to install this TypeScript execution environment for Node.js globally on our system. And that means that I can, instead of typing node, I can now do ts-node and specify the TypeScript file and execute that against Node.js. Now this is really useful for simple examples, but for more complex examples, this is not going to be a viable approach. So what I'm going to do throughout this course is that I'm going to be executing files that are simple, just to showcase a few things for you guys using ts-node. And when we get to more complex things, such as using modules and export and import statements, I'm going to change back to TSC, and we also take a look at how to utilize Webpack and how to create a bundle from all the TypeScript files and then use that bundle in JavaScript via Webpack. Let's start to take a look at the data types in TypeScript. And first we're going to discuss the most basic and therefore the most simple data type that you can use, and that is Boolean. So how do you define data types? Well, first of all, you create a variable, just as you would create a variable in JavaScript. And then we can assign a value to that variable as well. So since we're working with Boolean, let's say that this variable will have the value true. The way you define data types for TypeScript is that you place a colon character after the name of the variable, and then you specify the data type. And in this case, the data type is Boolean, and it's all lowercase. This means that if I now specify a non-Boolean value for isAdmin, so let's say this is now a string, then TypeScript is immediately going to complain and is going to tell us that true in a double quotes is not assignable to type Boolean, because if you place a variable in double quotes or in single quotes for Let's start to take a look at the data types in Typescript. And first we're going to discuss the most basic and therefore the most simple data type that you can use, and that is Boolean. So how do you define data types? Well, first of all, you create a variable just as you would create a variable in JavaScript. And then we can assign a value to that variable as well. So since we're working with Boolean, let's say that this variable will have the value true. The way you define data types for Typescript is that you place a colon character after the name of the variable, and then you specify the data type. And in this case, the data type is Boolean, and it's all lowercase. This means that if I now specify a non-Boolean value for isAdmin, so let's say this is now a string, then Typescript is immediately going to complain and it's going to tell us that true in double quotes is not assignable to type Boolean, because if you place a variable in double quotes or in single quotes for that matter in Typescript, it is going to be understood to be a string. Okay, so you get immediate type checking inside the code editor as well. If I were to run the Typescript compiler against this Typescript file, I will also get the error that says exactly the same, so type true is not assignable to type Boolean. So that means that we can only specify Boolean values for isAdmin. Just like in JavaScript, all the numbers that you can specify in Typescript are floating point values. And in addition to hexadecimal and decimal literals, Typescript also has support for binary and octal literals as well that were introduced in ECMAScript 2015. So let's go ahead and create a number. In order to specify the data type number, we use number as the data type. And if we have hexadecimal numbers, binaries, octals, you still need to specify the number data type. As you can see, all these declarations are valid in Typescript. And finally, let's take a look at the last primitive data type that Typescript supports, and that is string. So I can create a variable, specify that with the data type of string, assign a value to that. I can also specify another variable with the data type string, and I can use single quotes, and that is of course also going to be a valid declaration. So this is how you work with the primitive data types. So let's put together everything that we've learned so far. I'm going to create a new file called app.ts, and in here I'm going to put together a really simple application. So we're going to take an isAdmin boolean, a user and a welcome variable that are both strings, and if the user is admin, we just display hello and then the username. Otherwise we just say that username is not an admin. And I'm using some ES 2015 specific features here, namely the const and let keywords as well as the template literal syntax. Now we could run tsc from the command line to compile this file, but don't forget that according to our tsconfig.json, all the TypeScript files are going to be included. So instead, I'm going to specify files because I only want to run the TypeScript compiler against app.ts and no other files. And let's also remove includes ts files. I'm just going to comment it out. Let's go ahead and save our file and run tsc now. And tsc has now generated app.js for us. So let's go ahead and open that. And notice that the JavaScript version of our application is exactly the same as the TypeScript version of the application, with the exception that it has removed the data type declaration. So it has removed boolean and the two string data type declarations for isAdmin and user and welcome. Other than that, because we are generating ES 2015 compliant code, everything else is the same, so we are still using const and let keywords as well as the template literal syntax. Let's take a look at how you can work with some more advanced data types in TypeScript, such as arrays. So of course, in TypeScript we can create arrays, and there are two ways that you can specify types for arrays. One is to use the type of the elements followed by square brackets, and the second way is to use what is called a generic array type. So let's take a look at both of these examples. So let's say you create an array of numbers, and we have that array available. So clearly this array only contains numbers, so we can specify that the data type for this particular numbers variable is going to be an array of numbers. So you specify number and then the array symbol. So this is now going to mean that if I try to push an element into that array that is a string, TypeScript is going to complain, stating that 1, 2, 3 is not assignable to parameter type number. So I can only push integer values or numbers to this particular array. Similarly, I can create another array where I only have string values. In which case I cannot push numbers to this array. I can only push strings. So this is one way of specifying the data types for arrays, and I said there's a second way, so let's investigate that as well. So the second way uses a generic array type. So I'm going to create numbers again, and the generic array type looks like this. So you specify the keyword array, and then in angle brackets you specify the data type, and now we can specify the values for that array. Now probably you're wondering what happens if you have an array that has multiple types or a mix of types. So what if my array has numbers and strings? So in this case, how do we specify the data type? For this scenario, TypeScript has what it refers to as a union type. So the union type means that you can specify in parentheses the types that you want to use. So very simply, we need to specify that here we want to use strings and numbers and this is an actual array. So our array will contain a union of string and numbers, so a mix of strings and numbers. And this is going to be a valid declaration, so that now we can go ahead and push either integers or string values to this particular array. However, we cannot push Boolean values because a Boolean value is not part of our union type of string and number. We could extend this and say, okay, this particular array should also accept Boolean values. So we can extend the union type. And the generic array type declaration can also be used in this way. So we can specify mixed to be an array of a number or a string, and we can give values to that in this way. And if we want to add Boolean to this list, we can very easily extend the generic array type declaration. So these two forms of declarations are exactly the same. Strongly related to the array data type is the tuple type. And the tuple type allows us to express an array where the type of a fixed number of elements is known. So in other words, we can create a mixed array where we can specify the data types for the elements. So here we create a variable called mix, which is going to be a tuple that will contain strings and numbers. And we can then assign values to it. And when we assign the values, the first parameter should be always a string, and the second parameter should always be a number. If I try to specify the tuple elements in a different order, such as number and then string, then Typescript is going to throw an error, of course. And it's going to complain that number and string, so the order of those items in the tuple, are not assignable to the order that we have specified, which is string and number. There's one interesting benefit of using the correct data types in tuples that I would like to discuss with you as well. So let's assume that we want to get the first element from our tuple, which is identified by the 0 index. So that is going to be a string. And if we want to call methods on this, notice that by default the code editor provides us with string specific methods like lowercase and uppercase and substring and split and all the other methods that you can only use with strings. So this is why it's very important to actually use the appropriate data types. And if I change this to use the second element in our tuple, which is a number, only number specific methods are displayed here. So for example, things like toPrecision and toFixed. So Typescript is always going to adhere to this. So in conjunction with this editor, it's only going to offer us the methods that we can use on the appropriate data types. Outside the standard JavaScript data type, Typescript also supports a data type called enum. Other languages like Java or C# allows us to use enums, and this enum is really just a way of giving more friendly names to sets of numerical values. And they are very useful when a variable, especially a method parameter, can only take one out of a small set of possible values. So this would be things like, if you work on a card game, it would be the card types, hearts, diamonds, spades and clubs. It could be a status of a contract of an employee, like permanent or part-time, and other things like this, where you want to use these static constants. Let's go ahead and create our first enum. And to create an enum, we need to use the keyword enum followed by the name. So let's call this card type. And then we need to specify the static values for it. So we have hearts, diamonds, spades, and clubs. We can then create a new variable, specify the card type as its data type, and we can call card type and then dot hearts, for example. Now the enums begin numbering their members starting at 0. So in this case, hearts will have index 0, diamonds has index 1, spades index 2, and clubs index 3. You can actually check this by hovering your mouse over the appropriate element in the enum, and Visual Studio Code should give you the index number. You can also change the indexing by saying that, okay, hearts should have the index 1, and therefore diamonds will have index 2, spades 3, and then clubs 4. We can actually get the values of these items based on the index from the enums as well. So let me create another variable here called card name, which is going to be a string, and then call card type, and let's say the second index, and that is going to be diamonds. So if I log out card name to the console, we should get diamonds. If I change this back and remove the index association from hearts, then card type 2 is going to be spades. In Typescript, there exists a special data type which is called any. This any data type allows us to opt in and opt out of type checking inside Typescript. So what that means is, you could have situations where you get some data from an API and you're not sure whether that API is going to return you a number or a string. You can then create a variable with the data type of any. So for example, we expect some data to come in from an API, and we specify that to be of any value, and then we assign a value 4 against that. This is going to, of course, work, and even if we specify this data to be a string, because we have specified the any data type, this is still going to work. We can also use this for arrays. So remember when we created the mix array, we can have any as the keyword, and we can therefore have an array that contains numbers, strings, and even Boolean values. This any data type can also be used when you port your JavaScript application to Typescript. So of course this gives you some powerful options, because until you figure out exactly how to transform your JavaScript code to Typescript, you can use the any data type. But please remember that you should not use this any data type all over the place just because it is convenient. You should always try to stick to the appropriate data type definitions of string, numbers, or use the union data types if required. Or you can also use interfaces, and that is something that we'll take a look at shortly as part of this course as well. In Typescript, we also have a data type called never. So the never type represents the type of values that never occur. And an example would be a function, for example, where the function throws an exception, or a function where a value is never going to be returned. So let's take a look at an example by creating a function that returns the never type. We can now go ahead and call this function inside another function. So I'm going to create a function called fail, where I'm going to return the error function here. And what I want you to notice is that when we check the type for the fail function, that is calling the function where we specify the type never, Typescript infers that the fail function also has the never type. So this is how to use the never keyword. Another example to use the never keyword is for functions where the function is never going to return anything because it has an unreachable endpoint. And of course, that is in a situation when you have an infinite loop. So in this case, if you have code that looks like this, you have unreachable endpoint in your function, and therefore the function should have the data type never. Although please bear in mind that having such a while construct in your application is probably going to break the application itself. We also need to discuss null and undefined data types. So both of these actually have their own types in Typescript, which means that we can create a variable and specify the type of it to be either null or undefined. And then if we do that, the only values that we can specify for those is either undefined or null. Now, there's one more thing that we should discuss here, and that is the fact that Typescript allows us to specify the values null and undefined to variables where you have specified the data type to be, say, number. So let's take a look at an example. So I'm going to create a new variable called test again, and we will say that this should be a number, and we assign a value 1 to that. We can then take that variable and assign a value null to it, or even undefined. And as you can see, there are no errors in here. But this is of course not a really good solution, because the values undefined and null should be assigned to the data types of null and undefined. Luckily, Typescript comes with what is called a strict null checks flag for the compiler. So let's go ahead and open tsconfig.json and add a new compiler option, and this is the strict null checks, and the default value of it is false, but we're going to set it to be true. And once we do that, we can go ahead and open again the file that we've been working with, and notice that we immediately get an error that says type undefined is not assignable to type number. So with the strict null checks flag, we made it sure that the data types of number do not take the undefined or null values. So if you want to assign undefined for whatever reason for the variable, we need to specify the data type to be undefined as well, and then we can assign the undefined or null values against it. Otherwise, with this strict null checks flag, we can only assign the appropriate data types to the variables. When it comes to declaring functions in Typescript, we can specify the function to have a void type. Functions defined as void means that there is no return expression inside the function. So let's take a look at an example. Notice that Typescript infers that the type of this function is void, so we can actually be explicit and specify that in the function declaration itself. If we were to have a return statement of some sort in here, Typescript would immediately complain, stating that you have a return statement that is returning something, therefore the function cannot have a type of a void. So this void type should only be used on functions where the function itself is not returning anything. In the previous videos, we saw how we can use the never and void keywords with functions. Functions, of course, can also have types, and they can have those types not only for their return type, but they can also specify the types for the arguments that get passed into the function. Here's an example of such a function that accepts a name as a parameter that should have a type string, and the function itself also returns a sentence which is of data type string. We can of course pass in multiple parameters, and each parameter can have its own data type. If we return something other than a string, such as return 1 for example, we now need to either modify our return statement to be a string, or we need to modify the type of our function to be number. Either way, just remember that you can specify the type for the function that it returns, and also the types for the arguments that get passed in to the function itself. And remember, if a function does not return anything, then you need to use the void type on the function. Type or type alias in Typescript allows the creation of a new name for a type. Aliasing doesn't actually create a new type, it merely creates a new name to refer to that type. And if you've worked with Typescript, or if you've seen some examples of Typescript, you may have seen interfaces as well. So please remember that types and interfaces are different concepts, although they are very similar, but in a later video we'll explore how they are actually different. So let's create our first type, which is going to be called user, and it's going to be an object that has a name, which is going to be a string, and an age property, which is going to be a number. And now we can go ahead and create our own variable using this type alias. And notice that if we leave the object empty, Typescript is going to complain that the property name is missing along with the property age from this declaration, so we need to specify those. And once we've specified them, Typescript is no longer going to complain, and we have successfully implemented our own type, which is called user, which specifies an object with two properties, a name which has a string, and then age which should be of type number. Type assertions in Typescript are a way to tell the compiler that you're 100% certain about the type of a certain variable. So type assertion is pretty much like a typecast in other languages, but it doesn't perform any special checking or restructuring of your data. So it is very useful for situations where you know as a developer that a value at the moment is going to have a different data type at a later point in time. So basically you know more about a value than Typescript does. So we're going to expand on this example where we've created the type user, and we're going to go ahead and create an empty myUser object. And the typical scenario would be that once you have specified a myUser object, is that you would want to add an age property to this object. And you would do that using a standard JavaScript dot notation. And if you notice, Typescript is complaining that property age does not exist on type empty object. And this is of course correct because we have specified myUser to be of type empty object, and an empty object doesn't have the age property. So we could circumvent this and say that, okay, myUser is of type user. But then in this case, Typescript is going to say that, okay, you have now specified myUser to be of type user, but then it misses the name and the age property. So this is not necessarily a good solution. So what we need to do in order to solve this problem is to use type assertion. And there are two ways to apply type assertions to variables in Typescript. So the first one is that we're going to use the as keyword. So we're going to specify that myUser should be of type user. So we say myUser as user, and then we assign the age property to that, and we make that equal to 35. So in this case, Typescript is not going to throw any errors because now myUser, the variable, is of type user, which of course has an age property which has a type number, and we assign the value 35 to that. So this is one way of doing type assertion, or in other words, it is one way to tell Typescript that you know that myUser is of type user, and therefore Typescript should allow you to assign the age property with an integer value to that. So another way to do this is to use the angle bracket notation. So we specify the type in angle brackets, and then we say this is a type assertion to myUser, and then we can assign an age property to that without any issues. So these two statements that you see here are exactly the same, and they allow you to do type assertions in Typescript. Oftentimes in JavaScript, and therefore inherently in Typescript, we'll be working with objects. Now, working with objects means that we can specify data types for the object as well in Typescript. Let's go ahead and create an object just as we would do it in JavaScript. Now, in JavaScript, we can use the dot notation to add a property to this object. But you can see Typescript is complaining and says property age does not exist on type empty object. Now, the ideal way to fix this issue is to initialize the object with the properties that we want to use and assign values to that. And later on, of course, we can update those values. Now, another option would be to use interfaces, and we discuss interfaces later on. You will see how it is a viable solution as well. Now, when it comes to objects, most of the time we will be working with array of objects. So you would have something like users, which would then be an array of objects where each object has a name and say has an age. So the question is, how do you specify a data type for this in Typescript so that every object inside your array has a name and an age property with a string and a number data type? Well, it is very simple. You specify that users should be an object, and that each object contains a name, which is a string, and then an age, which is a number. And then we add square brackets after that, so we indicate that this is an array of objects. If you don't specify that, then Typescript is going to warn you that you need to specify this to be an array. Interfaces in TypeScript provide a powerful way to define entity that must conform a definition. So simply put, think about entities like nouns, such as a user, a purchase order, an address, a location, so on and so forth. And we can specify properties for these entities. So we can specify that a particular user must have a name and an age property. And since we are using TypeScript, we can also specify the data types for those. And because we have specified the data types, we can go ahead and use the type-specific functions once we have created an object based on the interface definition. So basically, interfaces are a way to making sure that objects that we create conform certain rules. So let's go ahead and create our first interface now, and it's going to be a very simple one. And the way we do that in TypeScript is by typing in the keyword interface followed by the name of the interface, for example, iUser. Now this is just a naming convention that I use here, so all the interfaces that I write have this capital I added to them as a prefix. And then we can specify what this interface should have, what properties it should have. So it should have a name property, which should be string, and it should have an age property, which should be a number. And then we can go ahead and create an actual user, and we can specify that this user must go ahead and implement the iUser interface. So that means that my user must have the name and age properties. So we must add a name, which is going to be a string, and we must also add an age, which should be a number. Now, of course, if you want to add another property here, such as an address, for example, then notice that TypeScript is immediately going to warn you that the address property inside the myUser variable is not part of the interface, therefore it's an unknown property. So this is something that we should also add to the interface if we want to use it. Interfaces also allow us to specify optional properties. So for example, what if we want to make sure that we have the address as a string as a property in iUser, but we want to use the address for people who actually have an address. Otherwise, for users who have a name and age, we only want to capture those, but not the address. So we can make this particular property optional, and we can do that by adding a question mark to it. So that means if I have an address property now for the myUser variable, it's going to be valid. If I delete this, myUser is still going to be a valid implementation of the iUser interface. Furthermore, we can also specify properties to be read-only. So for example, let's say that the age should be a read-only property, which means that we can specify the read-only keyword here. And if I now want to change myUser.age to have a different value, TypeScript will not allow me to do that because it says age is a constant or read-only property. So of course, since we have specified age to be read-only at the interface level, and the myUser variable, the myUser object that we have created implements that interface, it doesn't allow us to update the age. So interfaces are not only capable of describing how objects should look like, but they can also describe how functions should look like, so how function types should look like. So let's create another interface, and I'm going to call it iGreet, for example. And in here we can specify the parameters for this function. So we could specify that it should have a name parameter, which is a string, and it should have a language parameter, which should be a string as well, and this particular function should return us a string. So we can specify the function parameters and the return type of the function. So now that we create this function that implements this interface, that function must have two parameters of string, and it must also return a string. Now, please remember that the parameters, when you define a function, can be anything else. So the parameters do not need to match with regards to the name, but they must match with regards to the actual data types. So let's now create an implementation of this function. I'm going to call that hello. So that hello should implement the iGreet interface. So we can now actually create the function for hello, and as I said, the function parameters can have different names, but they must have the same data type. So we can specify those to be n and lang, and in the body of the function I'm just going to write a really simple logic. So if the language attribute is passed in, then we say hello, otherwise we say hola. And now we can go ahead and call this function, and the first parameter is going to be a name, and the second parameter is going to be a language code. So now our hello function is actually implementing the iGreet interface, and therefore it makes sure that the two parameters that we pass into the function are in fact strings, and that the function itself also returns a string. In an earlier video, we had a look at how to work with types, and in the previous video we also saw how to work with interfaces. So as you can see on my screen at the moment, I have a type alias and I have an interface definition as well, and seemingly those two things are the same. So remember that a type alias allows the creation of a new name for a type, and an interface provides us with a very powerful way to define entities that must conform a definition. So even though a type alias and interface looks the same, there are some differences in them. The first difference is that with an interface we can use the extends and implements keywords, and that is something that we'll take a look at later on. But with type and type alias we can't use the extends and implements keywords. An interface can also have multiple merged declarations, and a type alias for an object type literal cannot have that. So what does that mean? Well, that means that if we have an interface with exactly the same name, so if we have another user interface that has an address which should be a string, then notice that I do not get an error saying that I have a duplicate user interface. Typescript is going to merge these together. So if I now implement these two interfaces, this variable must have a name, which is a string, must have an age property, and must also have an address property. If I do not specify the address property, then notice I get a warning saying that property address is missing. So Typescript is actually merging these interface definitions together. But if I do the same for the type, you will see that if I create another type alias for user where I specify the address to be a string, I get an error saying that this user is now a duplicate identifier. So Typescript cannot merge type aliases together. So this is one of the differences between types and interfaces, and the other one was the fact that an interface can use the extends and implements keywords. Interfaces have the capability of extending each other. And TypeScript achieves this using the extends keyword. So that means that we can create an interface, we can create then another interface, and that newly created interface can extend the previous interface, and that means that the extended interface is going to copy the members of the existing interface. And this basically gives us more flexibility in how we have separate interfaces, and therefore we can use these separate interfaces for other reusable components within our application. For the purposes of this example, let's assume that we have a very simple interface called iPerson that has a name property that must be a string. So this would allow us to create person objects with a name property. We can then create another interface. We could call it iHero, for example, and we could say that this hero interface extends the iPerson interface, and we can specify additional properties for the hero interface. We could do something like superpower, which could be a string data type. Now we have two options. We can create a standard person that is going to implement the iPerson interface, which means all we need is a name property. But if we create another variable that implements the iHero interface, in this case we need to specify both a name and a superpower as well. Then in this case we need to specify a name and a superpower as well. Notice that if we remove the name, of course we are going to get an error saying that since the iHero interface extends the iPerson interface and that requires us to specify the name, we must specify that for every implementation of the iHero interface as well. So as you can see, this allows you to sort of slice and dice your interfaces according to requirements, and it allows you to create these nice reusable components. Previously we created this iUser interface that specifies how an object could look like. So it has a name, an age and an address property where the age is read only and then the address is optional. So this means that we can create an object that implements this particular interface. So we must specify a name at least and an age as well. But what if we want to specify additional properties for our object? And this could be because someone could programmatically add those, so we can't prepare for these in advance using the interface. Well, in that case, we can specify what is called an index signature. So we could add a new property in here, which is of type string, and it can have any value. And this means that we can add any number of properties now to the object with any values. And this also means that as of TypeScript version 2.2, we can use the dot notation to access any of these properties. In previous versions of TypeScript, we had to do something like admin user and then use the square brackets and then type in testing here to get the value. But as I said, this is only for TypeScript version less than 2.2. Before we look into classes and access modifiers, I wanted to take some time to talk about functions a little bit more. So functions allow us to pass in data types for the arguments, and they also allow us to pass in a data type for the return value. And because TypeScript is a superset of ES 2015 or the ES 2015 version of JavaScript, it also allows us to work with things like default parameters as well as the spread operator. And here's an example function that uses the data types string for 2 parameters, and it also uses a default parameter. So if no language parameter gets passed into the function, it defaults to en, and therefore this return statement is going to be executed. Otherwise, if another argument gets passed in, then we have this return statement, and if none of these are true, we just have a generic greet return statement in here. So what the TypeScript also allows us to do is to define optional function parameters. So an optional function parameter is demarcated by the question mark. Notice this third argument that we added with the data type of string, and we have added a question mark after the name of the argument, which means that if this particular function call has its third parameter, then we can act on it, and we're going to put an exclamation mark here. Otherwise, we're not going to deal with it at all. So we can try this, and we can have John in here, then we can have ES, and TypeScript is not going to complain if we do not add an exclamation mark, but we can add that as well so that our function signature matches the function signature as well. Just like JavaScript, TypeScript also supports classes. And you've already seen how to work with classes in JavaScript, and the implementation of classes in TypeScript is really no different. Here you see a very simple class called person, and the difference between using classes in TypeScript and using classes in JavaScript is the fact that we can add data types to the classes. So what we have here is a class person that has a name class member. We then have a constructor, which means that upon initialization of this person class, we need to pass in an actual name, which must be a string, and then we assign that name to the name class member that we have specified here. And we also create a greet method that should return us a string, and it returns us the sentence hello and then the name of the class member name. We can now, of course, go ahead and implement this class. And once we have implemented that class, we could call this variable myPerson and call the greet method, which returns us hello John. We can, of course, also extend a class. So here's another class called hero that extends person. And this particular class has a class member as well, which is called superpowers, which is an array of strings. In the constructor, we expect a name to be passed in to the hero class as well. So upon initialization of this class, we want to pass in a name, and then we call the constructor of the parent class. So we call super with the name parameter. Then we add two methods here, add power, which returns void because all it does, it adds or pushes a new element to the superpowers array, and then list powers returns a string of arrays because it just returns the actual array for the superpowers. So we can go ahead now and test this as well by creating a new variable and then calling the new keyword with the hero class. So that is going to instantiate our class. We can go ahead and execute this code and see what happens, and I'm going to be using ts node to execute our TypeScript file, and we do in fact get back one element in that array. So this is the only single element in the superpowers array. So you can see that classes in TypeScript work just like classes in JavaScript, because we can use things like constructors and the super keyword. In the few upcoming videos we will see how the TypeScript classes are different, so what additional things we can do in TypeScript that we can't do in JavaScript. There exists a thing in TypeScript called access modifiers. So access modifiers basically drive the behavior of class members. So the class member in this example is name and superpowers. And there are 4 types of access modifiers that you can utilize in TypeScript, and those are public, protected, private, and read only. When you do not specify any of these, then the public keyword is assumed. So what you see on my screen at the moment, when I have the name class member, that has the access modifier of public. So this declaration, where I explicitly tell public, is the same as what you saw before without the keyword public. So this public access modifier means that I can access the name class member outside the class person, which includes the subclass hero and also in the instantiated class. So I can just say batman.name and I can access the name property without any issues. Or I could also create a new greet method here to override the existing method that we have in person, and we can say return, and I can still access this.name, which is of course referencing the person.name property, which at the moment has a public access modifier. So let's see what happens when we change that to private. The private access modifier means that the name property, the name class member, can only be accessed in the class where we have declared it. So we can only access it inside the person class. And in fact, you see that in the subclass hero, we got an error that says property name is private and only accessible within class person. And after the instantiation of the class, we get the same message, so we can't access this name property. So this allows you to hide class members and disallow access to them in other classes. Protected is somewhat different from private, but works on the same premise. So protected means that the particular property can be accessed in the containing class as well as all derived classes, so all subclasses. And that's why in the subclass hero I can access name without any problem, but I cannot access it outside the class or its subclasses, so I can't access it after the instantiation of the class. And then read only is the 4th access modifier that we have, and that means that I cannot give a new value to name. You can see that I cannot assign a new value to name because it has been declared as read only, and I cannot make that change inside the code either. So I can't do that change inside the subclass because the read only property is applicable to the subclass as well. Now these access modifiers are not only relevant to the class members but also to methods specified for the class. So because I haven't specified any access modifier for the greet, the add power and list powers and the second greet method, the access modifier of public is assumed. But you can add private and protected access modifiers to any of these functions, and the functionality is going to be exactly the same to what we discussed with regards to the class member variables. There's an interesting relation between classes and interfaces in TypeScript, and that is what we're going to investigate in this video. So a class can actually implement an interface. So here we have a person class that is similar to what we've seen before, and I'm also going to add a new interface. So here we specify an interface called iPerson, which should have a name property. We can then go ahead and specify that the class person should implement that interface. And TypeScript achieves this via the implements keyword. So now our class actually implements the interface. So if I were to move this name class member variable away from the code, then you can see that the class person now incorrectly implements the interface called iPerson. Okay, so you can utilize these interfaces to ensure that your classes implement members that the interface specifies. Abstraction is an object-oriented programming concept where a class can specify how an inherited class should implement the class itself. So basically we provide an abstract class which only defines the class member variables and the methods that every other class derived from that abstract class should implement. And the reason for this concept is that we want to hide the complexity of the implementation from the inherited classes, and we allow them to implement the functionality themselves. So in light of this, we can create a very simple abstract class. And just like with every other class in TypeScript, we can specify class members, constructors, and methods. And notice that when specifying an abstract class, we actually need to type in the abstract keyword and specify the method to be an abstract method. So once we have the abstract class created, let me actually show you what happens when you try to instantiate this. You cannot do that because you cannot create an instance of an abstract class. So what you need to do instead is use the extends keyword. So we can create another class that extends the previously created abstract class. And in the newly created person class, we need to implement some of the properties and functions that we want to use, and those that we have specified in the abstract class. So here is our implementation of the abstract class. We can of course instantiate the person class now. And we can access the methods or the properties from our class. In the previous few videos you also saw that you can utilize interfaces with classes, so it's perfectly valid to create an interface, implement that interface for an abstract class, and then create a new class that extends the abstract class. So let's put everything together that we have learned so far with regards to interfaces and classes. So I'm going to create two interfaces, and we're going to create an abstract class, and then we're going to extend that class, and then we're going to create a subclass of the class that implements the abstract class. So let's create an interface first called iPerson, where we want to make sure that a person has a name, which is data type string, and an age, which is going to be a number. And then let's create another interface called iHero that pretty much extends the iPerson interface and adds a superpowers property, which is going to be an array of strings. So then let's create an abstract class as well called human, which is going to implement the iPerson interface. So that means that this abstract class must have a name as a string, an age as a number, and let's also add a constructor to it, where upon initialization of this class we need to specify a name, and then let's add this name to be equal to name, and let's add an abstract method called showAge, which will return us a number. So remember, because this is an abstract class and an abstract method, there's no implementation of this the class nor the actual methods in here. So let's then go ahead and create a person class which extends the human abstract class, which means that we need to have a constructor in there. So we need to specify that, and we can call super with name to call the parent of this person class, which is the abstract class of human. We can then of course need to implement the showAge method that returns us a number, so we need to return this .age. Okay, so let's then create another class which extends the human class as well, but it could also extend the person class. So let's actually do that. Let's extend person, and this hero class should implement the iHero interface. So in here we need to add a superpowers class member, which is a string of arrays, initialize it as empty. We're going to add a constructor where we create a name, and instead of specifying this.name, we can actually call super with name, so that we can reference the person class, which then references the constructor of the abstract class human. And for our hero we also need to specify two methods, so add power, which could be used to add to the superpowers array, so we can access that by calling this.superpowers and then push the power to that array. And then let's also have another method called listPowers, and this is going to return us an array of strings, of course, because it's just going to return this.superpowers for us. Okay, so we have created a bunch of things here. Let's now create a new hero, say Batman, and now we can add an age to Batman. We could also call add power and add a power here, and we could also of course go ahead and call list powers. So let's just log everything out here with regards to the powers and save this file and execute it and see what happens. So if we run this file, we of course get the power listed that we have added. We can of course add additional things in here, and then rerunning this application would then return us all these values. Now this application works, but I have one small issue with this, and every class, abstract class and interface that we have is in one single file. So we should do modularization of our code, which means that the interfaces and the classes would be in separate files, and therefore in app.ts we could only do the implementation of those. We could only instantiate the hero class. So let's actually go ahead and do this, and the way I'm going to do that is by creating first of all a new file and call that iperson.ts, and this file is going to contain the interface iperson. So I'm going to copy this, paste it in here and type in export default and have this interface ready in there. Then I'm going to take the iHero interface and I'm going to create a new file for that as well, call that iHero.ts, and I'm going to do export default in here. And notice that because iHero extends iPerson, we need to import that. So I can do import iPerson from and then specify iPerson.ts. The .ts extension is optional. Okay, so far so good. So let's also take this abstract class human and put that in a separate file. And also do an export default here, and also import iPerson from iPerson. Okay, so far so good again. So we need to create two more files, one for the class person and one for the class hero. So let's go ahead and do that. So I create person.ts. Let's go ahead and copy this and let's see. Okay, so this now requires us to use human. So that's our abstract class. So let's do export default here, and then we can do import and then call human from, and then the file is abstract human. Okay, so that's done as well. And last but not least, let's go ahead and add hero.ts, which is going to be a hero class. Copy this part from the code, paste it in here, do an export default here, and we need to bring two things in. We need to bring person and then the iHero interface. So let's import iHero from the appropriate file, and let's also import person from the person Typescript file. And now all we need to do is import hero from hero.ts in this main file, and this is where the implementation is. So you can see we have reduced the size of app.ts quite a bit, and if we run the application we still get the appropriate results. Programming languages like Java and C# have long been using generics in order to create reusable components for applications. Typescript also supports generics. So what do we mean by reusable components? Well, we're going to go through an example so that you better understand it. So let's assume that we are working on a card game, and we write a function that allows us to randomly pick a number from a set of numbers. And that could be implemented in this way. So we have a function, pick number, that accepts an array of numbers, and then we get a random value out of that array, and then that is going to be our picked number. Now, since we're working on a card game, it's perfectly acceptable to also have a function in there that allows us to pick a suit. So diamonds, clubs, hearts, or spades. So the function for that would look like this. So we have a pick suit function. It accepts the array of suits as a parameter, and then using the random index, we can go ahead and pick one of these randomly. Now, what I want you to notice is that even though these two functions do separate things, the implementation of these functions are the same. So the first function creates a random index, and then based on that index and based on the argument that gets passed into this function, it selects a random value, and the same happens for the other function. So this is a perfect example where we can use generics in TypeScript. So as opposed to having two separate functions, we can create one single function. So let's go ahead and create a generic function that will handle both the number picking and the suit picking as well. And this is how it would look like. And this is a generic function because the name of the function is appended with angle brackets and with a capital T. Now, generics are denoted by these angle brackets, and please note that we could have used any other identifier for generics other than capital T, but this capital T seems to be the de facto standard, and that's what other people would be using, and that's what you would see at various examples. So the bigger function takes an argument of any type and returns that type as well. So if we pass in an array of numbers, it returns us a number. If we pass in an array of strings, it will return us a string. And this is exactly what we wanted to do. So let's take a look at an implementation of this. So here we have a suits array, a numbers array, and then we can use the picker function to pick the numbers and pick the suits. And if we run this example, you will see that it in fact works in the way that we wanted it. So this generics allows us to pick randomly a number and a string value as well. And all we had to do was create one single function that is a generic function, as opposed to having two functions where the function signature would have been exactly the same. In this video, we're going to continue with the course by discussing types and typings in TypeScript. So far we have discussed that TypeScript supports data types, and we had a look at primitive data types and some special data types that are relevant to TypeScript only. And you also know that JavaScript is an untyped language, which means that we can pass data around freely. So we can specify strings and numbers and integers for any variables without any restriction. Now, of course, this could lead to potential errors, and that's why the type system of TypeScript is very beneficial. So we can say that a certain variable is of type string and another type of variable is of type number. Now, there are a lot of libraries out there that you want to use in your project. So for example, jQuery, or you think about Node.js as well. Node.js has a bunch of modules like the file system, the FS module, and so on and so forth. All of these libraries and frameworks that were written in JavaScript by default do not have typings because of the untyped nature of the language itself. And typings allows you to essentially add types to these third-party JavaScript libraries so that you can make use of the TypeScript type system. Now, typings actually exist for multiple libraries out there, and there are people who are creating these type definition files. So you know, if you are working with an additional library in TypeScript already, and if you see files that have a .d.ts extension, that is a TypeScript type definition file. And that file does one simple thing. It essentially tells you what types a given library is using. So in light of that, let's take a look at an example, and let's say that we want to make use of underscore, the underscore library in our application. So if you Google this, you will find that underscore has typings available, and typings can be installed via npm. So all we need to do is type in npm i -- save and then add types / and then the name of the library that we are after and underscore. So of course, first you need to make sure that the library that you want to get typings for exists in this repository, and if it does, then you can install it via this command. So you can replace this with npm i -- save, add types, and then / followed by the name of the library. Okay, so since we have installed the types, let's also install underscore itself so that we can use it in our application. Okay, so we've installed underscore and we have also installed Types-4 underscore. Now this means that since you're writing TypeScript code, we can now do something like import everything as underscore from and then specify underscore as the library. And what that means is that now we can access all the methods from underscore itself. So let's go ahead and create a very simple example where I'm going to specify this users variable, which is an array of objects where each object has a name and an age. And I can now very simply use that underscore variable that I have created in the first line of the code and call any of the underscore methods available. So for example, max, and let's go through users. And you can see that Visual Studio Code can give us some hints as well. So I can see that maximum list, and I have a list here for my users that I have specified. So name, string, age, number, so it understands these data types. And I'm going to pass in this callback function here and users.age. So I'm going to get the entry from my users array where the user's age is the greatest. So that's what this max function does. So let's also log this value out, and let's go ahead and test this solution. Okay, and I in fact get that object back because age 33 is the highest age that I have here. Another example for typings is a typing for Node.js. So we need to also install that. So let's go ahead and install that via npm i -- save, add types / node. So this is going to install typings for Node.js itself, which means that now I can do things like import star as fs from fs. So I can import the file system API of Node.js, and I can go ahead and call all the methods available. So for example, read file sync, and I could read test.txt. And notice that in this case, the file variable is going to have the data type buffer. So I could actually be very explicit and specify this, and I don't need to wait for TypeScript to infer that the data type for the constant file is going to be buffer. However, notice that if I change the read file sync method, and if I pass in a second argument, which is of course the encoding, so UTF-8 is a valid encoding, then TypeScript is going to complain that now the read file sync method returns us a UTF-8 encoded string, and that is of course no longer a buffer, so we can specify the data type for this as well. So you can see that using these types for the various libraries and frameworks that are outside the scope of TypeScript, and that they use the untyped feature of JavaScript, can help us to write some better code, some better maintainable code, and some code that is more strict with regards to the data type. So it's not going to be that forgiving as JavaScript itself. So far we have only executed our TypeScript applications using the command line. So we either used ts-node or we have used tsc, the TypeScript compiler, to compile JavaScript files. Now in this video we're going to take a look at how to integrate TypeScript with a build tool. Now build tools include things like gulp, grunt, and there are some others as well, but we are going to take a look at Webpack. So Webpack is one of the build tools that allows us to put all of the assets, which include JavaScript and TypeScript and CSS and fonts and files and everything else, into a dependency graph. Now what is this going to mean for our situation is that we're going to create a Webpack configuration file. We're going to configure our build tool so that it builds a single JavaScript file from all the TypeScript files that we have. So in light of that, I went back to a previous example where we had the app.ts file that imported the hero, and then that imported the interface, and it had extended an abstract class. So I'm going to use this example because it will demonstrate how an application could be developed. So it has multiple modules and how these modules are linked together, and what we can do with Webpack to create a single bundle file from these individual TypeScript files. So the first thing that you need to do is install Webpack if you don't have that already, and we need to install that globally. So that's npm-i-g and then Webpack. Once you have installed Webpack, you also need to make sure that you have TypeScript installed locally. So type in npm-i-save TypeScript, and we're going to install another thing that we will need, which is going to be ts-loader. And I'm going to tell you what this ts-loader is in just a moment. Okay, so we have these two packages installed and we are ready to configure Webpack. So Webpack configurations live in this file with the name of webpack.config.js. So this is the default configuration file that Webpack is looking for. And since this is a JavaScript file, to set it up, it's very easy. We have a module.export statement, and inside this module export statements, we can specify a bunch of rules. So I'm going to specify a few things. First of all, we need to tell Webpack the location of the entry file. So the entry file in our case is going to be app.ts because this is the main application file that we are using. Once we have set that up, we can also specify an output. So the output file name should be something on our file system, something like dist and bundle.js. So this is going to be the file that gets created and that is going to contain all the code from TypeScript in a JavaScript version. Then we also have this section called module, and in this module section we are going to set up a rules section. So rules is an array of objects, and it requires us to specify something called a test and a loader. So this rules property here is relevant to Webpack 2, which is the latest version of Webpack. In previous versions, I believe this was called loaders, but please note that loaders is going to be made deprecate by Webpack, so try to upgrade your Webpack to Webpack 2 at least and use rules. So what is this test? So test, in our case, is going to be a regular expression, and we're going to be testing for files that have a .ts extension, and Webpack is going to find all these files and is going to apply a loader to it, and this is where we specify the package that we have installed, which is ts-loader. So essentially Webpack is going to call the ts-loader library and apply that to all the files with the .ts extension. So if we save this now, I can already tell you that this is not going to work, but let's go ahead and see how we can use Webpack. So in the same folder where you have the Webpack configuration file, Because we have installed Webpack globally, we can just type in Webpack, and Webpack is going to automatically take the configuration file here, but it's going to throw us an error that says it can't resolve hero in this file app.ts. So if you remember, in app.ts we are importing hero, but we are importing it without an actual extension. So we could have done this, but then Typescript prefers us to import files without their extension. So the way to solve this is that we need to go back to our Webpack file, and we need to tell Webpack to automatically resolve files with an extension. And in order to do that, we need to add a resolve property here that has an extensions array, and we specify .ts. So now Webpack will automatically resolve all the 5 references in our application code with a .ts extension. So if we save this and rerun Webpack again, notice that it goes through all our files, and it basically went through app.ts, hero.ts, person.ts, extract human.ts as well, and it has created a bundle.js, which we can go ahead and open. So there's a dist folder now that has bundle.js, and there's going to be a lot of things in here that are specific to Webpack, but essentially you will see that our application code is in here as well. So you can see here we have the class, and there are some other bits and pieces here. What this means is that now you can take this bundle.js code and put it into a browser, for example, or very simply we can now just execute it against Node.js as well, and this is going to run just as standard JavaScript code. So that's why I said you can take it to the browser now, and you could run it inside the browser as well. In this video, we're going to be discussing linting our TypeScript code. So first of all, linting is a term or a verb that is used when we talk about checking the source code of applications for potential errors and mistakes. So historically speaking, lint was a Unix utility that was able to flag suspicious program behavior, but these days it is used, as I said, as a verb to spot statistical errors and some other mistakes in our code. So basically, you can set up a set of rules. Those are linting rules that say, for example, no console.log statements should be allowed in the application, or you should be using single or double quotes for strings. How do you specify functions, whether you use 2 spaces or you use a tab. So these are all the things that you can set up as part of the linting rules, and then the linter can enforce these rules. And all the programming languages these days would have their own linters, and even things like CSS would have their own linters. And we're going to be using tslint, which is the linter for TypeScript. In order to install tslint for our project, we need to execute this npm command here. So that's npm i --safe-dev, and tslint is the package that we want to install. Once this is done, and since we are using Visual Studio Code, we can also go to the Visual Studio Code Marketplace and install an extension called tslint. So you can search for that. And this is the extension in question. So this is a tslint extension to Visual Studio Code, and you can click the install button to install this, and once it is done, you can hit this reload button to reload Visual Studio Code itself. Okay, so this is now done. Once we have installed all the dependencies, we can go ahead and create a tslint JSON file. So that is going to be the configuration file for our linter. So the way we do that is by specifying the node_modules folder .bin tslint, and then we do --init. So this is going to start the tslint, and init is going to create a tslint JSON file. And by default, as you can see, this tslint file extends the tslint recommended setting. Now there are a bunch of rules that tslint provides us that they believe they are recommended. We can of course change this, but let's take a look at now what happens when we use these recommended rules. So now that we have the tslint JSON file in place, open a Typescript file, you will see some errors in the file, such as this one here that says tslint. So this is a linter related error. Call to console log are not allowed because we have the no console rule set. Now, if you want to exclude a file from linting, so an entire file, you can specify a comment on the top of the file and say tslint disable. In this case, notice all the errors are gone and I will no longer see the errors. But this is not something that you should do. And you can specify tslint disable and then the name of the rule, which is no console. So in this case, other errors from tslint are going to be present, but the error for the console is not going to be present anymore. Another way to do this is of course to open the tslint file, and under rules you can specify the rule that you are after, like no console, and you can specify whether this rule should be true or false. So if we set this to false, then of course this error message from tslint is going to go away. If you're using Visual Studio Code, that you will also see that you have, where you have the terminal window, a problems tab that says 3 at the moment. I can click on this and tslint, because we've installed the extension, will also tell me all the lint errors in here. So what are the errors in here? So let's fix some of these. So it says single quote should be double quote. Okay, so let's go ahead and change that. Then here it says identifier Batman is never reassigned, so we shouldn't be using let, but instead we should be using const. And there's one more error here that says file should end with a new line, so let's add the new line there. And now app.ts adheres to the tslint recommended rules that we have installed. In the previous video we saw how linting works and we applied linting to app.ts. But of course our other files also have some issues, and it could be a very tedious task to open up the files one by one and then checking the files or the problems tab in Visual Studio Code and then fix those. So a much better way would be to use Webpack and get Webpack to check the TypeScript code for us. Now luckily there exists a tslint loader that we can use. So I'm going to install that as a developer dependency, and it is called tslint-loader. So once this is installed, we can go back to the Webpack configuration and we can add another rule in the rules array. And just like before, we're going to test for all the TypeScript files, and we are also going to call the loader, but it's of course called tslint-loader. And there's one more thing that we're going to add here to this rule, and that is going to be enforce, and it's going to be called pre. So we are enforcing this rule to run before the TS loader. So first Webpack is going to apply linting, and then it is going to create the bundle. So we can go ahead and run Webpack now and see the result. Okay, so we got a bunch of warnings for each of our files. So first of all, in hero.ts there's a bunch of warnings. In app.ts, in person.ts, we have warnings everywhere. Okay, so let's go ahead and fix those. So let's go and open hero.ts and let's fix these one by one. So I'm going to go ahead and do this, and I'm not going to bore you with that, but I'm going to go through all of these and apply the appropriate fixes. Okay, so I have fixed all the files, and now if we run Webpack again, you will see that the bundle.js got created, and Webpack no longer complains about any stylistical errors produced by the linter. So far we have created an application that uses multiple TypeScript files, and it uses modules, and then we've used Webpack not only to create a bundle.js file, so a JavaScript file under the dist folder, but also to do linting to make sure that our code adheres to certain stylistical rules. Now what we're going to do next is create an index.html file under the dist folder and put a very simple HTML content in here. So we're just going to serve bundle.js. So what I'm going to do, I'm going to go into the dist folder, and from that folder I'm going to launch this Python simple HTTP server to run on port 8080, and this will just allow me to view this particular index.html file in a very simple way. So I have my browser open here, and you can see that in the console under developer tools I do get the two array values just as before. Now I can go under debugger and I will see that of course I have bundle.js as one of the sources, and I get that big JavaScript file that Webpack has generated. Now the problem is that in this case I cannot tell where the code came from, or whether I had this class hero as a separate file or not, and how that file got structured. But of course we can do something about it. So let's go back to our editor, and there's going to be a few things that we're going to modify. First of all, we're going to go to our tsconfig JSON file, and under compiler options we're going to specify that we want source maps to be generated. So we're going to set source maps to be true. Then for our Webpack configuration, we also want to make sure that we enable source maps, and we do that by adding a new entry in here called DevTool, and we're going to use something called an inline source map. And we don't need to install anything special. Webpack is going to automatically generate inline source map for us. So what we need to do, of course, is quit this process, go back to the app folder and rerun Webpack so that bundle.js gets generated again. And if you open this file now and go to the very bottom, you will see this source mapping URL information in here. So this is the source map. In other words, this particular stuff that you see here, even though it looks like gibberish, it is a mapping between the bundle JavaScript and the original source files. So let's go ahead and run the Python command again. Go back to the browser, refresh this, and now notice under sources we can actually expand bundle.js. Let's expand that further, and voila, we have the original source files here. So all the TypeScript files in their original format. Furthermore, I can add breakpoints to this now as well. Refresh the application and notice that the debugger is going to pause the execution of my application. I can investigate the local variables and inspect everything in here, so I can see that the Batman variable is of type hero. It has an age and name property and superpowers with these two values as well. So this helps us immensely to do debugging inside the browser. Now, some of you may not have gone down the Webpack route, which means that you are still using TSC to transpile your TypeScript files to JavaScript. And that works for single files, but when you have an application such as the one that we've been working on so far, where you have multiple files, ideally you would want to create a bundle. So if I just run TSC now, notice that each and every TypeScript file in this particular folder is going to generate a JavaScript file, which is good, but as I said, it would be a lot better if we would have a single bundle when executing TSC. Let me just remove all the JavaScript files from here, and let's see what we can do to generate such a bundle file. Well, first of all, let's go ahead and open tsconfig.json, and we need to specify a few additional options here, and the first one is going to be out file. So let's add this, and let's specify this bundle.js. So this bundle is going to contain all the TypeScript code transpiled to JavaScript. Now when you use this out file option, you need to also specify a module. And as you can see, there are a bunch of options here that we can use for modules. However, out file can only be used with either system or with AMD. So I'm going to be using system, and that means that we want to use the system.js module loader. And I'm going to add two more things in here as well. Inline sources, set that to true, and inline source map, set that to be true as well. So by setting these two things, I make sure that I can debug my TypeScript code from the browser. Okay, so that is now done. So let's now run TSC, and notice that we will get a bundle.js file in here, and that contains all our code transpiled to JavaScript. But we're not done yet. So notice that the last thing that system.js registered is this thing called app. So we need to tell system.js that this is our application, and it should start our application by calling this part of the code. Notice we also have the source map in here as we requested that. So how do we work with system.js? Well, let's go ahead and open index.html. And the first thing that I'm going to do is going to be to bring in system.js. Now, I could have installed that via npm, but this is just a simpler solution. So I'm pointing this script tag to a CDN, and I'm bringing system.js from there. Then I need to add a script tag, and in there we need to import our bundle. So to do that, I need to call system.import and then bundle.js. And then I'm going to have an arrow function in here. I'm going to call system.imports, and then I'm going to import the application. And then I will also have a catch statement just to capture any errors and bind those to the console. So once I'm done with these two things, I can go ahead and enter that folder and fire up the Python HTTP server. Browser open, so let's go to localhost 8080, and I do get the response here inside the console. And if we click on debugger, you will see that bundle.js is a source that we have, and if we expand that, we get all the original TypeScript files in here as well, and we can, just as we did before, add breakpoints and then take a look at the values for the variables that we have. So we have Batman here, so we can inspect it. It has an age, a name, superpowers, so on and so forth. So far we had a look at how to create bundles using system.js and a webpack. So of course, let's also take a look at how to create an AMD asynchronous module definition bundle from TypeScript files. So what we need to do is going to be very, very simple. We need to go into our tsconfig.json and change module to be AMD, save this file, and just rerun tsc. So that is going to now generate a bundle for us that uses AMD style modules. And we have the source map as well, just as before. And notice that the last thing that we have defined here is the app. So this is the main application, so we need to remember that, of course. So we can go ahead and open our index.html file, and we need to first of all bring in require.js, which is going to help us to utilize this AMD module style JavaScript bundle. Then we also need to bring in the bundle that we have created as well. So let's specify bundle.js here. And the last thing that we need to do is very simply call require that accepts an array. And the thing that we want to require is going to be app. And that's all what we need. So now we can go to the dist folder, fire up the Python HTTP server, open up our browser and go to localhost 8080 and we get the response here in the browser. We can go to the debugger and we get of course the sources as well, and we can add debugging and do everything else that we have done before.